Welcome to Lesson 9. When are they the same? Let's use equations to think about situations. So we're going to jump right in with our warm-up, which is going to be found on page 63. Which one would you choose? So we have two scenarios here. Imagine babysitting. Would you rather charge $5 for the first hour and $8 for each additional hour, or $15 for the first hour and $6 for each additional hour? Take a couple minutes to think about which one you would select. Meet me back here so we can discuss it together. Okay, so let's take a look. So I like to use a table to organize my thoughts. So here we are. In the first column, I have the number of hours. In the second and third column, I have amount earned. So we're going to look at the first scenario first and use the second column for that. So we know that in the first hour, we're going to make $5. Each additional hour, we're going to make an additional $8. So I'm going to add $8 to get 13. And I'm going to keep adding $8. Okay. So I'm going to go 21, 29, 37, 45, 53, and 61. All right. So I'm going to do the same thing with my second scenario. So the first hour is $15. And then every additional hour, I am adding $6. So I have 21, 27, 33, 39, 45, 51, and 57. So I want you to notice in my second column, you'll notice that each time that it changes by 1 hour, the amount that I'm getting paid goes up by an additional $8. For the last column, each time that it changes by 1 hour, the amount that I'm earning goes up by $6. Okay, so it asks us which one would we rather have, or which one would we rather do? And I don't know how you answered, but for me, it's going to depend. So one thing that I noticed looking here is that if I work 6 hours, I get paid the same thing no matter the situation. If I work 6 hours, if I work less than 6 hours, notice how my money is greater. The amount of money that I earn is greater. However, if I work if I work greater than 6 hours, my money over here is greater. So let's think about that. When I'm looking at these two scenarios, and I'll say the first one is scenario A, and the second one is scenario B. Scenario A is the better choice if I'm going to babysit for more than 6 hours. Scenario B is the better choice if I'm going to babysit for less than 6 hours. If I'm babysitting 6 hours, the amount that I'm going to earn is going to be the same. Next, we're going to take a look at water tanks. So we're going to look at the amount of water in 2 tanks every 5 minutes, and that's going to be shown to us in a table. So I want you guys to start looking at this table, and I want you to think about what is happening in each tank. Okay, so you can either draw a picture to describe this. You can write a few sentences. You could type it in your Edpuzzle. But I want you to share with me what is happening in each tank. So I'm hoping that you notice that in tank 1, what is happening with our liters of water? They're going up. They're increasing. Now, with tank 2, what's happening with our liters of water? As the amount of time passes, I have less water in the tank. So the amount is going down, right? So again, in tank 1, the amount of water is increasing. And in tank 2, the amount of water is decreasing. So the next thing that it wants us to do is to use a table to estimate when the tanks will have the same amount of water. So looking at the numbers here, when do you think they'll have the same amount of water? If you guess that it's going to be somewhere around 15 to 20 minutes, then I would agree with you. Why is that? Because those numbers are closer in that time frame than they are at any other point, right? Now, I will say that I think that it's going to be closer to 20 minutes than 15. Okay. But it's definitely going to be between 15 and 20 minutes. The amount of water in liters in tank 1 after T minutes is 30T plus 25. The amount of water in liters in tank 2 is negative 20T plus 1,000. Find the time when the amount of water will be equal. When the amount of water will be equal. So I want us to understand something real quick. So I want us to think about this in terms of X and Y, because that's what we have dealt with some in the past. So I want to notate that our time is our X and our water level. Our water level is our Y. Okay. So with that being the case, with time being X and our water level being Y, this question wants us to find the time when the water levels for both tanks are the same. Okay. When the water level for both tanks are the same. So if they're the same, that means both of them have the same exact Y. Okay. So remember, these equations are written in terms of Y. So they've given you the expression. So I want you to remember that when we were doing slope intercept form, it was Y equals mx plus b, right? All right. So where m was our slope, b was our Y intercept. So let's take tank 1, for example. This one is 30T plus 25. Okay. So that's what it would look like. Y equals 30x plus 25. So if both of these equations represents the water level, and both of these tanks are at the same water level, that means I can set these two expressions equal to each other. We on the same page? Okay, so let me clear my board real quick, and then we're going to start that. So I got 30T plus 25 is equal to negative 20T plus 1,000. So I'm just going to solve for T. So I'm going to add 20T to both sides. And I'll get 50 T's on the left plus 25, 0 T's on the right, and 1,000. Then I'm going to subtract the 25 on the left and from the right, and I'll get 50T is equal to 975. Well, 50 T's equals this. I just want 1 T. So I'm going to divide both sides by 50, and I'll get T equals 19 and a half minutes. 19 and a half minutes. So what does this mean? After 19 and a half minutes, tank 1 and tank 2 will have the same level of water in them. If I want to know what that level of water is, what can I do? I can substitute. So I can substitute my time into each of my expressions to find my water level. So remember, at this time, the water levels are the same. So I would get the same number. And it is 610 liters. 610 liters. So remember earlier, they asked us to estimate when the tanks will have the same amount of water. And we said it was going to be between 15 and 20 minutes, but that it would be closer to 20 minutes, right? Well, we just figured out the time in which their water levels will be the same. What was our time? Remember, it was 19 and a half minutes. So were we correct? Because where would 19 and a half minutes fall? It would fall between 15 and 20 minutes. And like we said, it would definitely be closer to 20 minutes. Here they ask us, if you didn't know which expression in the last problem belonged to which tank, that should be tank, not take, to which tank, how could you figure it out? So how could we write an expression here with tank 1? So 1, I want you guys to remember, how do we calculate slope, right? How do we calculate slope? How do we figure out our y-intercept? Well, if we look at just that first row, we already have our y-intercept for both of our tanks, right? So if I look at my y-intercept for tank 1, I know that that's 25, so that's going to match that expression. And if I look at my y-intercept for tank 2, I see that that's 1,000, which matches the second expression. So we would be able to figure it out by looking at the y-intercept because it's included in the table. So we want to use what they gave us. If it wasn't included in the table, then we can pick any 2 points on the table, find that slope and the y-intercept. How did we find the time that the two water heights were equal using those expressions? What did we do? Well, we set them equal to each other. We set those two expressions equal to each other because we knew that the water levels were going to be the same, right? And these expressions are written in terms of the water levels, which means these expressions should equal each other if the water levels are equal, right? So then we did that, and what did we do next? We just solved for T. Next, we're going to talk about elevators. A building has two elevators that go above and below ground. At a certain time of day, the travel time it takes elevator A to reach height H in meters is 8/10 H plus 16 seconds. The travel time it takes elevator B to reach height H in meters is negative 8/10 H plus 12 seconds. I want us to take a look at number 1. It asks us, what is the height of each elevator at this time? So when they ask us at this time, they're expecting us to look at this picture and determine which elevator is which, number 1, but also number 2, what is the actual height of the elevator? So if it's right now, if it's where the elevators are at this point and no time has passed, what do you think that means for the variables that are included in our expressions? If you're not sure, let's start by looking at our X and Y. Okay, now even though they're not using X and Y, I always bring it back to this because that's what we're used to seeing in our coordinate plane, right? So I want to bring it back to X and Y. So X in this case is our height. And Y in this case is our time. Okay, so Y is our time. So again, if they're asking us where the elevators are right now in the picture, this is likely where they start. Okay, so if it's where they start, that means 0 time has passed, which means if we're looking at elevator A, we'll do elevator A in black. If we're looking at elevator A, that means this expression is equal to 0, right? Because remember, Y equals mx plus b, right? That's our general form. So that means our time is 0 and our expression is equal to it, okay? So what I'm going to do now is solve for the height that elevator A is currently at, okay? So I'm going to start by subtracting 16 from both sides. Okay, so I'll have negative 16 on the left is equal to 8/10 H because those 16s equal 0. Now I'm going to divide both sides by 8/10. And I get H is equal to negative 20. So based off of that, which one of these do you think is elevator A? Okay, so we see ground level is right here. If this is ground level, okay, that means up would be positive numbers and below would be negative numbers. So which one is elevator A? This one would be elevator A. All right, so let's look at elevator B. So we want to do the same thing because we're trying to figure out its current height. So no time has passed, so that's the 0. And we're going to set it equal to the expression that they gave us. I'm going to start by subtracting 12 from both sides. So I get negative 12 is equal to negative 8/10 H. I'm going to divide both sides by negative 8/10. And I get my height is equal to 15 meters. So that makes sense, right? That makes sense because this one is above ground level. So it is currently at 15 meters. How long would it take each elevator to reach ground level at this time? How long would it take each elevator to reach ground level at this time? So what do they mean? If we're trying to reach ground level, what do you think that means? That means H would be what? it would be 0, right? So if h is 0, let's look at A, for example. That means we have 8/10 h times 0 plus 16. Well, any number times 0 is 0. So it's going to take elevator A 16 seconds to reach ground level. What about elevator B? So again, our height is 0 because we're talking about ground level here. Any number times 0 is 0. So it's going to take elevator B 12 seconds to reach ground level. If the two elevators travel toward one another, at what height do they pass each other and how long would it take? So if we're talking about the height that they pass each other, they're going to be at the same height at that time, right? So that means at this point, the heights are the same. But what else is going to be the same? The time that has passed. So that means we can set these expressions equal to each other and then solve for the height, then use the value of the height to find out how long it'll take. So let's do that. So we know that elevator A, we have 8/10 h plus 16, and elevator B is negative 8/10 h plus 12. So we're going to solve for h. So I'm going to start by adding 8/10 h to both sides. Once I do that, I get 1 6/10 h plus 16 is equal to 12. Subtract 16 from both sides. 1 6/10 h is equal to negative 4. So now I have to divide both sides by 1 6/10. Once I do that, I get that my height is going to be a negative 2.5 meters. So what does that mean? That means 2.5 meters below ground, okay, below ground level. But how do we figure out the time or how long it takes? Well, I can take either of these equations. So I'm going to use a different color here. So let's look at this elevator. I'm going to substitute. And I'll get negative 2 plus 16, which is 14. So that is 14 seconds. Now, again, I could do the same thing with the other expression. Negative 8/10 times negative 2.5 plus 12. I'm going to get positive 2 plus 12, and I get 14 seconds. So notice how the heights are the same as well as the time. The times are the same. So those elevators will cross paths. They're going to be at the same height, which is 2.5 meters below ground level, after 14 seconds. If you are on an underground parking level 14 meters below ground, which elevator would reach you first? So how would we figure this out? What did they give us? They gave us the height. Okay, so we're looking for the time. When it says which one is reaching you first, they're trying to figure out who's going to get to you faster, okay? So in the least amount of time. So what I'm going to do is I am going to do some substituting. So I'm going to substitute 14 for h in both of my expressions. And we're going to see who arrives at my level in the least amount of time. So whenever I multiply 8/10 and 14, and let's pay attention to the fact that we're 14 meters below ground level. So this isn't just a positive 14. This is a negative 14. So we got to make sure that we're paying attention there, right? So when I look at the first one, 8/10 times negative 14 is a negative 11 and 2/10. Negative 8/10 times negative 14 is a positive 11 and 2/10. So with elevator A, when I add the two, this has me reaching, or them reaching me in 4 8/10 of a second. For elevator B, they're going to reach me in 23.2 seconds. So if I'm in a hurry, which elevator do you think I need to take? Of course, elevator A. It's the one that arrives in the least amount of time. It's going to be there in 4 8/10 of a second. Today's goal was I wanted you guys to be able to use an expression to find when two things like height and time are the same in a real world situation. Time to move to your cool down. If you have any questions, you can add them to the discussion board. The notes are in Canvas, and don't forget that your interim assessment is tomorrow.